We're Group 10, and we are focusing on the analysis and redesign of a personal coffee maker for our project. Personal coffee makers are used to brew smaller amounts of coffee for consumers. Cold water is first poured into a separate compartment of the coffee maker and is then boiled and strained through coffee grounds to brew either a pot of coffee or an individual serving of coffee for the consumer.
The target customers for our project will be those who enjoy consuming coffee and need individual-sized portions. We plan on providing 150,000 units. The primary customers for these units will be those who plan on using this coffee maker for personal use at home, and the secondary consumers will be those who plan on using it in community use, like a restaurant or an office.
All right, so here's our fast diagram. Obviously, the basic function of any coffee maker is to brew coffee, and we've broken those down into two very basic functions, which is to boil the water and filter the coffee. So boiling the water, we add heat via the heating element, and we contain the fluid via the water tank. For our filter coffee, we want to do three things. We want to contain the grounds so that the boiling water can act on it. We want to expand the grounds so that it brews properly. And then we want to strain those grounds out so there are no grounds in your coffee when you go to enjoy your cup. We want to ensure dependability by maintaining pressure. So we don't want any leaks. We want that boiling water to be able to rise up through our unit and then onto the grounds. In order to ensure convenience, we want to prevent the user from getting burned by guiding pouring, by directing the boiling water so the user doesn't have to interact with any high energy sources, and we want to direct the coffee that is made and allow it to cool before the user handles it. We like to collect the coffee either via decanter or a mug, and we like to set the brew time so the user can just set the time and have it ready in the morning when they're ready for it. In order to enhance the product, we'd like to automatically stop heat. That allows the coffee to not burn in the decanter. And we'd like to allow for single cup brewing, which is done by our single cup adapter for our individual user. Lastly, in order to please the senses, we'd like to increase flavor or enhance flavor by increasing the contact time. That is, the amount of time the boiling water acts on the coffee grounds to give it that rich flavor.
For our bill of materials, you can see a bisected view of our coffee maker. In total, there are 37 different parts, most of which are made of varying plastic, though some are metal. We estimated costs based off material, estimated manufacturing price, assembly cost, tooling cost, and the total cost of our entire assembly is estimated at $79.88.
All right, so this is our first fishbone diagram, first assembly sequence. You can see that there are a number of sub-assemblies that are getting put together in parallel and then eventually getting brought together down in that assembly sequence at the bottom right. So for our scoring, we said the ease of transfer and handling is a 1. There are a number of pieces that have only one position that they fit for an alpha and beta of 360 degrees, so that gets a score of a 1. The ease of locating parts, a couple small holes, but most of it is pretty well guided, so that gets a 2. Ease of fastening and joining. There are a number of small screws, especially in the heater element, heater subassembly, but for the after that, the main housing is snapped to fit, so that gets a 2 as well. Ease of testing subassemblies. The heater subassembly can get tested, get powered on with the circuit board before it's assembled, but the full functionality, you have to assemble the entire thing before you can really test it. So it gets a 2. Ease of assembly in parallel. As you can see, we're assembling a lot of stuff in parallel, so that gets a 2 as well, for a total score of 9 out of 15. All right, so here's our second fishbone diagram. You'll notice that the components within the subassemblies may have moved around a little bit, but overall, the sequence of the subassemblies have not changed. There is not too much flexibility in how we're able to assemble this product, and the ease of assembly has not really improved that much. That is why you see the score a 9, like the last assembly, out of a total of 15.
This is our function component mapping matrix. On the left-hand side are all the components we've identified in our bill of materials. Along the top are all the functions from our FAST diagram. Every function has at least one component on it, and every component is attached to a function.
For products family, we decided to go with a cup stand. This would target our primary consumers, which are individual users of our device. The cup stand allows for single-use cups or mugs to be placed closer to the nozzle to reduce splash and in turn reduce potential burns. How it works is the bottom rectangles insert into the cavity and keep the stand in place. We estimate the cost of a cup stand to be about $1.96.
Looking at our functional differentiation table, the only difference between the customer groups is the allowance for single cup brewing, which is a function of the cup stand, which is targeted more towards our primary customer group.
Taking the results from our functional differentiation table and the component mapping matrix, we were able to identify two modules that would allow for more efficient production of the product. Since the variations between models are based on serving size, the rest of the coffee maker remains the same. Therefore, we identified the majority of the parts as platforms, with the single-use stand and the jug as interchangeable modules.